Hello and welcome to part 4 of Dev Maths and Stats Refresher Course, Lecture 4. Now we move on to 3 related concepts which are very useful when working with matrices. That's the identity matrix, inverse matrices, and the determinants of a matrix. So first of all, we look at identities, and for any size of square matrix, there's just one very important matrix called the identity matrix. And it only works for square matrices. So for example, for 3 by 3, the identity matrix is that one. 3 by 3 identity matrix I call I3, because we can also have I2 for 2 by 2, I4 for 4 by 4, and so on. To see why it is called identity matrix, we can calculate some examples. So if that's matrix B, if I then take the identity matrix and multiply it by matrix B, so this is identity times matrix B, the answer that comes out is exactly the same as B, so B has not changed. You should be able to check this by hand. If I reverse the order, so I do matrix B times identity matrix, then I get exactly the same answer again. So with the identity matrix, it does not matter which order you multiply it in. It still does not change the other matrix at all. You can also use identity matrices with rectangular matrices. So this one here I can multiply by the 3 by 3 because it has 3 columns. So I can multiply that by the 3 by 3 identity matrix, and I find again it does not change. If I look at a simple, it's not gone off the screen. If I look at a vector like Z, I can multiply this by the 3 by 3 identity matrix because it has 3 columns, so it's possible to multiply. And again, it does not change. And here I can transpose a matrix like this and then multiply that matrix by I3 and it doesn't change. So any matrix at all, you multiply it with I3 and the identity matrix will not change. So if you compare this to ordinary numbers, which we call scalars, it's very much like the number 1, because 1 times 7 is 7, 1 times 23 is 23, 5 million times 1 is 5 million. It doesn't change numbers when you multiply. So that's identity. If we move from that to the idea of inverse, for any ordinary number or scalar, you can find another number so that when you multiply them, you get back to 1. So if I give you 6, you can give me 1 over 6, because 6 times 1 over 6 is 1. If I give you negative 1 million, you can give me negative 1 over 1 million, because that's, when you multiply them, you'll get back to 1. So for a square matrix, the equivalent is you want to find another square matrix so that when you multiply them, you get back to the identity matrix. If you can do that, then the second matrix is called the inverse. So if you have a square matrix M, if you can find one which we write as M minus 1, if this times this is equal to the identity matrix, then this one is the correct inverse matrix for M. Now, what's really important is, unlike with numbers, often it's not possible to find the inverse for every square matrix. Quite often it's not possible. In fact, there's one number also where it's not possible, but maybe you can think about that, for only one number. Maple can calculate the inverse, obviously, where it's possible, but you should be able to do it for this course by hand for a 2 by 2 matrix, just to show that you get the concept. So I'll just give you some examples of this. Here's matrix A. This is how Maple calculates to the power minus 1, gives you the inverse. And just to check, if I multiply this by this, I get the identity matrix. So this is the correct inverse. This is matrix C. That's the inverse. If I multiply them, I get back to the identity. And for a 2 by 2, there's F. There's the inverse of F. And this is how you get, to check, you multiply this by this, and you get the 2 by 2 identity matrix. So here we've got 3 examples of matrix and how to find the inverse, matrix, the inverse, and then matrix, the inverse. you should notice that the process of finding from here to get the inverse involves dividing by a number. So here we divide by 41. Here we divide by 107. Here it's not sure, it's not clear what we divide by because it has cancelled out and simplified. So this 41, this 107, this other number, this number which we divide by, that number is the determinant of the matrix. So the determinant is part of this process, and it's also used for other things. So because it's so important, we'll make sure we spend a bit of time on it, and I'll make that the subject of the next video. But for now, thanks for watching.